going to understand the today Leetcode question. So let's understand and see the today questions. What we have is okay. So let's go and understand. So today we have 1857, right? Largest color value in a directed graph. So what is largest color value in a directed graph, right? So let's understand the statement first, right? So there is a directed graph, right? There is a directed graph means there will be given a directions, right? As you can see the example, and from 0 to 1, 0 to 2 we have given here, right, the direction. So it is saying there is a directed graph, right, of n colored and m edges, right? Edges we have, right? We have n colored node and m nodes we have given. Okay, so we have given a directed graph in which we have given n colored nodes and m edges. Got it? Now it is saying that the number has been made on the nodes are 0 to n minus 1, right? So we have n nodes, right? We have n nodes that is colored, but it is from what? 0 to n minus 1, and these nodes are, you can say, colored, right? And what we have edges, right? M edges we have given. Okay, now it is saying that you are given a string color where color of I is the lowercase English letter representing the color of ith node in the graph 0 indexed, right? So it is also saying we have given color like this, we have given, right, A B A C A, right? And it is saying that if we have given color, right, and that is colors, and that is in, you can say, in a string A B A C A, right, like this, right? If this is given, so so if you have index, right, if you have given index, right, so each index of this is represents a color of the ith node, right? So it is saying that color of I, colors of I is the lower English letter, and it representing the color of ith node in the graph. You got it? Now it is saying that you are also given to the array that is called edges, where is at j is a and b, indicating that there is a directed edge from a to b. Okay, means we have given this is also, right? So this is we have given 0 to 1, right? So for 0 to 1 means there is a direction between 0 to 1. Next, what we have given 0 to, right, it means there is a direction between this 0 and 2, correct? Right? First given 0 to 1, then it is given 0 to 2. Now it is given 2 to 3, right? So now we have a direction between 2 to 3. Another what we have 3 4, means we have a direction between 3 to 4. So like this we have given. Got it? And the next line is saying, right, what is saying? A valid path in the graph is a sequence of node. So we have a valid path in the graph in a sequence of node x1 to x2, x2 to x3, and xk, right? Like this we have given. So a valid path in the graph in a sequence of nodes we have, right, such that there is a directed edge from x1 to x plus 1, xi to xi plus 1, you can say, right? So for every I, right, that is between 1 to k, the color value of the path is the number of nodes that are colored, right? So color value of the path, here I am reading, the color value of the path of is the number of node, right, that are colored, most frequently occurring color along the path. So we have to return, what we have to return? We have to return the largest color value of any valid path in the given graph, or -1 if the graph contains a cycle. Okay, we have to return the largest color value of any valid path in the graph, or -1 if the graph contains a cycle. Got it? Largest color value. Now understand the explanation that we have given here, right? So the path we have first is 0 to 2, 2 to 3, and 3 to 4, right? This is one path, and another path what we have 0 to 1. So as you can see here, right, as you can see here, the large you can see the valid path. What will be the valid path? Because see, we can consider this one also 0 to 1, but this is not the longest, right? This is a small path, you can say, but this is the big path from here to here. If you consider 0 to 4, it is coming how many nodes? 1 2 3, right? So 3 nodes that are colored actually, right? And that's why you can see, that's why the first color is, this is the first one color, this is the second color, and this is the third color, you can say. We cannot consider this one, we can consider only this one, 1 2 and 3, right? So 3 nodes that are colored, right? And we can say that is what, that is in the red, right? We can see in the red color we have this one, and this one is in the maximum color. This is not the maximum color, right? So 3 color that is coming in this one is max color, you can say, most frequently colored along this path, right? Let me repeat again, you can summarize again. Repeat is not a good word. So if we summarize this one, right, so this is the path, you can say, actually we are considering, in which this color, red color, is coming frequently, right? And that's why the we have to return the largest color value. This is the largest color value, and that is what, how many, 3 times it is coming, and we have to return, right? If we are not having, then we will return -1. Okay, but we are getting this one, so we will return answer 3. Okay, so actually it was asking, like, it was you can see this graph, it was saying that we have n color nodes and we have m edges, and we have given the color, right? We have also given a string, right? So based on that we have to find out, right? And so that we can say, if you see here, right, what we have given, a and a we have given, right, for each one. So 0 is nothing but a, right? B we already know. This again, it is 0, a is coming, right? Means this is also a, this was also a. Next we also, what we have, 2 and 3, right? This is 2 and 3, so it is coming what, a again, right? Like this. So we are getting a each time, right? And that's why a is the color answer, you can say. Next we will understand this example 2, in which we have given this example, right? So what we will do, let's understand color A we have given, and we have given edges. So self edge we have, right? Means we don't have the path, right? Because it is a self node and we don't have any path. This is just a cycle on that will be returned -1. Constant we have given like this, and all the colors is in the English lower letter, right? Now think about the solution, right? See, we have this question, right, and we can implement either using Kahn's algorithm, right, and using depth first search, BFS, or topological, you can say any other way like union, you can do this, right? So either we will implement this one or this one, so we will see these approaches, right? And let's understand this one, right? So we have given the solutions, right? So we'll try to implement here how the topological sort will use here. Okay, so to find the maximum frequency of a color, right, whenever you want to find the maximum frequency, right, anywhere, right, so to find the maximum frequency of a color in directed graph, we must either, right, we have to iterate over the path, right, in such a way, if we have the maximum frequency of all the color, right, of the path for the path ending at u, let's suppose. Okay, so we are traveling from one index to one node to another node, right? So we will use it to calculate the frequency of the color, right, of all the color for the path. We will use outgoing edge from u. Okay, so if there is an edge from u to v, right, the path ending at v will have the same color of the frequency as the path ending at u, correct? So except that color of v will be incremented by 1, right? Means if we have, there is an edge between what, from a to sorry, we can say u to v, right, and the path ending at v, right, will have the same color frequency as the path ending at u, right? The path that is ending at u have the same frequency when we are reaching at where, v. Then what we'll do, we'll increment by 1. So now if we do this for all the nodes, right, then what will happen? If now we will do this for all the nodes that have incoming edge to v, right, then what will happen? We will take the maximum frequency of each color, then we'll take the maximum frequency of each color across these edges, right? So it is trying to say that, right, we are going from u to v, right, and the path ending at v, right, and path ending at u. If path ending at u have the same frequency that we have at v, then we will increment by 1. Now if we do this for all the nodes, right, that have an incoming edge to v, in that case we will take the maximum frequency of the same color, each color of these edges, and will have the maximum frequency of all the color path ending at v. So after covering all these edges, right, going into v, we can use the maximum frequency of all the colors that is stored in v for edges going out of v. Got it? So like all the edges coming to v, right, all the edges, all the nodes that have an incoming edge to v, we will take the maximum frequency of each color, right, across these edges, and we will have the maximum frequency of all the color for the path ending at v. That is done. Now we will do, after covering all these edges going into v, we can use the maximum frequency of all the color stored in v for edges going out of v. Got it? Now third thing we'll do, we will notice that if each edge u to v must first obtain the maximum frequency of all the color path ending at u, only then we can we form an answer for the path ending at v, you can say. So this leads us to consider topological sort, right, to solve the problem. So topological sort, or you can say topological ordering of a directed graph is a linear order, right? So topological sort, or you can say topological ordering of a directed graph is linear ordering of its vertices. So for every directed edge, you can see, so such that for every directed edge u to v from vertex u to vertex v, u comes before v in the ordering. So in a directed acyclic graph, means where we don't have cycle, we can use Kahn's algorithm, right? If we don't have cycle, there should not be a cycle, right? There is a directed, means direction will be there from u to v or any node a to v, right? But there is not should be a cycle. That is called a cyclic graph, directed acyclic graph, directed or cyclic graph. In that case, we can use Kahn's algorithm to get the topological ordering, right? Why? Because see, the topological order topological order, or you can say topological sort ordering, you can say, of a directed graph is a linear ordering of its vertices, all the vertices, linear ordering. So for every directed edge from u to v, from vertex u to v, right, what will happen? U comes before v in this ordering, because direction between u to v, that's why u will come first and v will come later. Okay, so it is saying in a directed acyclic graph we will use the Kahn's algorithm, right, to get the topological ordering. So Kahn's algorithm works to keep track of the number of incoming edges in each node, that is called in degree. Correct? So I was talking all these things only to discuss, only to make you understand the in degree, right? So you have to understand the in degree, right? If you already knows, that's very good, right? So Kahn's algorithm only works to keep track of the number of incoming edges into each node, that is called in degree. So it works by repeating visiting the node with in degree of 0 and deleting all edges associated with it, leading to decrement of in degree for the nodes those incoming edges are deleted. So this process continue until no element with the 0 in degree can be found, right? Got it? So first of all, what we have to understand? First of all, we have to understand that in a directed or cyclic graph, we will use Kahn's algorithm to get topological ordering, right? Next, we have to understand Kahn's algorithm works by keeping track of number of incoming edges into each node, and that is in degree. And it works by repeating visiting the node with an in degree of 0 and deleting all the edges associated with its, leading to a you can say decrement of in degree, right? For the node those incoming edges are deleted. Okay, so how we'll do that? So it is saying, so we have to visit the node with an in degree of 0 and deleting all edges that is associated with, leading to decrement of in degree for those nodes whose incoming edges are deleted. So this process continue until no element with 0 degree can be found. I think you got it. Okay, next we will understand. Okay, so now we will understand, we also need to detect if a cycle in a graph, right? So if there is a cycle in a graph, right, we will return -1, that we have already seen, right? If there is a self node and we are going to on this node only, means we are cycle, I will return -1. So the advantage of using Kahn's algorithm, right, is that also aid in the detection of graph cycle. If there is a graph, right, if a graph cycle is there, we will return -1, right? So this is the benefit of using Kahn's algorithm. Okay, so how Kahn's algorithm perform, let's understand. So let's perform Kahn's algorithm, or you can say directed graph having a cycle. Here is a visual steps representation how it work, right? So first 1 is coming, then 2, then this, and you can see it is forming here cycle, right? So visiting node 1 and 6, delete outgoing edges from them, right? So we have already visited this one and this one, so we will remove this one and this one. So as you can see, we have removed the node 1 and 6, right? Now we are visiting node 5, so we will visit the 5 and we will read outgoing edges, right? So actually these are outgoing edges, from it is going from 0 to 2 and 6 is going to 6 to 5, right? So outgoing edges we will deleting each time. So now we are visiting 5, so we will delete node 5 outgoing edge, as we have already done with 6 and 1, correct? Now as you can see, 2, 3, 4, right, will never be visited. Why? Because they still have in degree equal to 1. Okay, so if we remove outgoing edges, right, if we remove the outgoing edges, in that time in degree will what happen? still have 1, because out degree will, after removing the out degree, the in degree should be 0, right? As we have see, there is no in degree, right? So if we have this direction from here to here, right? We have removed, let me clean this one. What I'm talking about, if we have here, right? So this is out degree, right? It is in degree for here, right? So here if you'll see, we after removing this, the outgoing arrow has been deleted connection, similar for this one, right? But what about this one, right? After deleting this one, in degree will remain same, right? 1, and that why we'll say this is a cycle here. So what we will understand till now, we can see that if there is a cycle, right, the in degree of a node in the cycle cannot set to 0 due to cycle dependency, right? And we are unable to visit the cycle node. So if the number of visited node is less than the total number of nodes in the graph, we have a cycle. So to solve this problem, we will create 2D array count with n node, n rows and 26 column, where n is the number of you can say a graph node, right? And we have an array of size 26 for each node to store the maximum frequency of each color across the path that end at that node. So we use Kahn's algorithm to perform the topological sort, and a pop-up node, you can say, indicate that all of its incoming edges have been processed, right? And it can now use to iterate over all its outgoing edges. So for each node, right, to its neighbor edges, we use count of neighbor of I equal to, will take the max of color, max count of neighbor I and count of node I. Because see, we are using we have to iterate over you can say all its outgoing edges, and to do that, see, each node have connected with its neighbor node, and to do that we have to take a count of we will take a count, right, and count of neighbor, you can say, that have the max of its neighbor, right, and its you can say its node, right? So we use max here instead of just setting it, because there could be multiple ways to reach neighbor, right? So for all I, so we also need to count the color of node. So so when the node is popped or pushed out of the queue, we decrease the frequency of the color of the node by 1. So we will make an answer variable to compute the answer, and will update it every time the node is popped out, and we do this for all the colors of node, and the answer will get from what answer, and will have the count of node of the color, and which color maximum, that will be our answer. Okay, first we'll do the max method max, and we'll pass our answer, and then what will happen, we will do the count of the node and its color. So you may notice that we will update answer each time. We will update the frequency of the color using the outgoing edges of the node, but only the node color is sufficient, right? You don't need to perform anything else. This is because of any path with the highest frequency of a particular color can be shortened it by starting from the third node with that color, or keeping the same color, same count of the color on this path. So as a result, simply we will use the color of the node itself, suffix the answer computation, you can say. Next, this is the algorithm in which we are saying that we will create a variable that is called color, right? We'll take an answer and will perform. So you can pause this and you can see, right? Coming back to here, what we have to do, first of all, this function signature is given, right? So we'll get our, you can say, let me zoom a little bit, okay? I think this will go right. Okay, yeah. So what we'll do here, first of all, we'll do n equal to colors dot length, and we'll get our length, right? Next, what will happen, first of all we'll do adjacent matrix will get, and then we'll get our in degrees, right? Now what will happen for all the edges, right? One by one edges will get it. We'll check the adjacent matrix dot compute if absent, and we'll do what, let me come here. Okay, next what will happen, first of all we'll take adjacent matrix compute if absent is will take, and its neighbor will take as 1, right? Is at 0, it is connected with is at 1, right? So you will get node a, node u, and this is node v, right? And what will happen, we'll mark this one, and we'll add on each node, we will say this is your neighbor. So in this way we know that we used to do what, adjacent matrix initialization, right? Node u will come here, and node v will come here, right? And we'll take the in degree, right, of 1. We'll updating our in degree for this one, because see, from u to v we are going, right? From u to v, in that case, give me 1 minute. Okay, so for u to v what will happen, we will go, so for all the v, right, there is a we have to increment the in degree if we are initializing. If the adjacent matrix now initialized with u and v, u is u from u to v is a direction, right? It is means it is mapped, it means we have to increase the in degree of v, you can say. I think got it, right? Now we will have our count of 26, right? English character, right? So for that we will take a count, and we'll 6 and then to 6. Okay, n is number of node, and 26 is the color, right? Now we will understand, so this will be our 2D array, right? Now we'll take q, so q will take as a linked list, and we'll put all its we will take in degree of I. If equal to 0 means we will push all the nodes with in degree, that is having 0 in the queue. So we'll check in degree if, give me 1 minute. So we'll check in degree at some value I. If it is equal to 0, we'll put into the queue. Now coming back to here, what will happen, we'll check answer at 1. Answer will take 1, and nodes sin will take 0. We'll check empty, will get from the node, q from the node, and we'll check the max. Answer will be 1 at initially, and plus count will get from what, class.char at node minus a, because we are assigning some value into the, you can say, count, right? And this is the node, right? So we will have this one. So after, if it is incrementing, color is incrementing, for this color is getting incremented, so we'll get our answer updated each time. And so that nodes seen will also do plus each time. Now if we'll do we'll check this node is on the adjacent or not. If it is not, right, we will continue, right? And if it is there, then what we'll get, we will get its neighbor, and we'll go for all its 26 I from I equal to 0 to 26. We are trying to update the frequency of the color for the neighbor to include the path that use node to its neighbor is, right? Because we have already passed our node, now we have to move to all its neighbor. And to do that, what we have to do, we have to do count neighbor I, and we'll get what, math.max count neighbor, right? And we'll pass I, and count node and I. Which one will come max, that will get updated to its neighbor I. And in degree will do what, -1 will reduce the in degree each time after doing this, right? Because see, if we are going to u to v, right? Now we are at v, so after removing this arrow, what we have to do, we have to check what is the value of in degree, because we have to reduce after removing the arrow, we have to check after removing the arrow, right, the direction. If the in degree is 1, right, means this is in the cycle, and that's why we'll check, right? So what we'll do, in degree at the neighbor, if it equal to 0, we'll do q.offer, we'll put into the queue, otherwise we'll continue the same thing that we have already seen. So we'll see node seen is less than n, and question mark will do -1. Actually we are doing what, node seen is less than n, then we'll provide -1, otherwise we'll provide what, answer. So this is what we are talking about, this all the things, right? So coming back to here, let's summarize once again. We have n nodes we have, then we have the matrix we have, then we have in degree, right? And here what we are doing, we are adjacent at 0 and adjacent edges at 0 and 1 means nothing but u is having the point to v, right? So what will happen, we are incrementing in degree at v, right? For this in degree, what is the in degree, because we are pointing from u to v, right? So for in degree of v is doing, we have to increment 1 because this is 1, right, in degree, and that's why we are doing plus plus here. Now what will happen, we have count, we'll take a 2D matrix like this, we'll take number of nodes, number of column will be there, right? For this 26 letters, and we'll have here, right, 26 letter will come in this way, and 26 color will be there, right? Let's suppose this is the index. So for this index there is 26 characters are there, so we have to take like this. So color can be different, right? So if this is a color, this node have colors something. So let's suppose see if there is a color, right, and there is node 1. So if the node contains what, the value is a, we'll take like this a, right? So that we'll take count like this here. Okay, no, you know the queue, and then what will happen, we'll check, we'll push all the nodes with the in degree 0 in the queue, right? If the in degree at I, because we are getting, we will initialize all the in degree. Now we'll check if in degree is equal to 0, we'll put into the queue dot offer, right? And what will happen, one by one we will poll out and we'll check it's all neighbor, right? So this is the way we have to find our answer, math.max answer, and their count, we already have this count, right, that we have already seen this count. So from this we will pass the node and its color, you can say this color we are talking about, right, this color, and we'll update our scene plus plus. After this, if this node is not visited on the matrix, right, we'll continue. Otherwise what we'll do, if this node is already visited, we'll get its neighbor for I equal to 0 to 26 letters, right? What we'll do, we'll take count of neighbor and I, and count of node and I, means we'll get the value from here, and we'll update our count, you can say count of neighbor I will update. And once our in degree, once it is done, right, means we have to remove the, you can say this arrow, right? And to remove this, right, we'll do minus minus, and then what will happen, we'll check again in degree of all the kids, right? Because we are from parent node, we are coming to child node, right? So parent node we have removed, we are going to now this one, we will go to the next node, right? So if this is the next node we have, right, so we'll consider only for this. So for we have to remove this in degree, and we are doing the minus minus in degree of this node. So this can be further here. So what we'll do, we will reduce this one, we'll continue this one, right? So for this way we will doing this line of code, right? We'll do minus minus first, and then we'll check if in degree is 0, we'll continue its neighbor. And now finally your nodes seen we have already done. If all nodes is less than n, we have not covered all the node, it means what, there is a cycle, okay? And that in that case we will return -1. If that is not the cycle, means we have node seen is always greater than equal to n, and in that case we have to return our answer. I think you got me. So if you have any doubt, please ping me in the comment box. Now coming back to the time complexity, right, what we'll do, if we have the nodes we have given, n nodes we have given, and m edges we have given, as per the example we know that, right? So we will get O of m plus n. Similarly we'll the space will get O plus m plus n, right? Take a pause, read this one, so you will get the more answer. Talking about the depth first search, right, you know the depth first search, right? So in the previous approach what we have done, we have obtained the maximum frequency, right? And better what I'll do, I'll create the another part of this video. If you like this video, so you can ping me in the comment box, I'll go through the next approach, right? And thank you for watching this video. If you like this video, please hit subscribe and comment. And if you want the another approach depth of search, please ping me in the comment box. Thank you guys, thank you for watching this video.